This is not actually a 3D model. It's a 2D image of a 3D model being rendered and manipulated in real time. This technique uses render textures and cameras. It's a really useful trick that game developers can use to take the output of a camera and render it on a texture in real time. In this devlog, I'll be breaking down how render textures work and how I use them to build two major systems in my game: the character preview in the equipment menu, as well as the minimap. First, I want to build a character preview for the equipment menu, one that you can rotate around and see your full character, similar to how it works in WoW and many other MMOs. But you see, we have one problem. Rendering 3D models on top of a canvas in Unity is more difficult than it sounds. For the best performance, we need to keep our UI canvas as a screen overlay. This means that the UI is drawn directly on top of the screen, which means it's always in front of anything being rendered in the scene. But we want our character to be shown in front of the UI. This is where render textures come in. Here's how it works. We have another 3D model of your character, with its own camera. We create and assign a render texture as the output of this camera. That means that instead of rendering to the screen, this camera will only render to this render texture. We switch the projection type of the camera to orthographic instead of perspective, and then we set the culling mask to only the layer that the player is on, and change the background to a solid black color. Now in our character menu, we can add a raw image for the character preview, and we can assign that same render texture to it. Now we write some code to rotate the character model based off some UI click and drag logic. By clicking and dragging on the character image, it will rotate your character model. The camera will capture this rotation and output it to the render texture, which will then update and be displayed on the character image. Easy, right? Anytime you have multiple cameras rendering in a scene, your performance is going to take a big hit. So when working on a system like this, we need to make sure that we make it as performant as possible. We should lower the resolution of the render texture, and in addition, we should have complete control over how often this camera renders frames, as we don't need it rendering every single frame. But more on that later. Now, let's talk about the minimap. This uses a very similar technique to what we did earlier. We place a top-down camera directly above our character in-game. This camera will stay on a fixed Y-axis, but will follow your character on the X and Z axis. We create a new render texture for the minimap, and we set the output texture of the camera to that render texture. We switch the camera to orthographic, and we set the culling mask to only the layers that we want rendered in the minimap: the ground, the trees, the buildings, etc. Then, we add a raw image where we want the minimap to go on our UI, and we assign our minimap render texture to it. Now as we move our character in-game, our top-down minimap camera will render to that render texture, and it will be updated on our minimap image in real time. As I said before, these types of systems dealing with multiple cameras rendering at the same time need to be extremely optimized, or it can severely hurt performance, especially with ones like this in which our camera is having to render out a lot of objects. For this minimap system, we lower the texture resolution on the render texture, and we write a script to control exactly how often this camera renders frames to the render texture. I tested with and without the post-processing and shadows on this camera, and it also doesn't really seem to affect the performance at all, so I'm just going to leave it on for now. That's pretty much it for this devlog. Make sure to like and subscribe, wishlist the game on Steam if you haven't yet, and join the Discord if you want to help playtest the game. Peace!